Hello everyone, welcome to Summer of HPC program. My name is Irem and my project friend is Carlos. Let's go detail about our project.
The max cut problem is very used in statistical physics. And let's see what it is. The main goal is to divide the node graphs into subsets. For example, if node 0 is in one subset and node 1 is in another subset, the connection between them, the connection number 3, is cutted, like this. So we need to divide the graph in these two subsets to get the maximum connections cutted.
The first thing is, what is branch and bound algorithm? It's the solution approach that partitions the feasible solutions space into smaller subsets of solutions. You probably don't understand anything from this explanation. So imagine you have a problem with some variables and want to know the maximum value of your result. To get this number, doing a lot of mathematical operation, for example semi-defined programming, and getting the upper and lower bound. Congratulations, you now have a root node. We must test the solutions within these bounds to determine the best one. The next thing we will do is branch two new children and compare their results. Branch root node with x2 variable and solutions are higher than lower bound plus 1, so let's branch again. First branch with node 2 and x third variable. Solutions are smaller than lower bound plus 1, so prune these nodes. Then branch node 3 and control solutions. Finally, you finish all three and you have seen that limits set by root nodes are correct. This is all for branch and bound algorithm.
The MPI master worker approach, or sometimes called master-slave approach, is the most used in parallel algorithms. So it's like in an office, a boss knows all the things that needs to be done, and the workers, in that case the employees, are the people who really do the work. So in our case, the master knows all the graph information and sends to the slaves the node to evaluate, and the best lower bound get it till this moment. The slave evaluates this node and sends back the information evaluated to the master. This process needs MPI send and receive routines and could cause a delay or idle time during the synchronization between master and slave.
Second approach that we implement is one-sided. It's different from the two-sided because a process can do a put or a get operation, writing data to or reading it from another processor without that other processor's involvement. To do this, you have to initialize this shared area. MPI window is used to do this. Then others can reach this area and can do what they want. For our problem, we want to have something like this. Imagine process 0 starts and have two nodes. One of three processes take this node and compute. Each process can share its nodes, and so on. To make this, we develop two versions in one-sided approach. In first approach, when process 0 has more than one node, inform the other three processes, and one free process get this node. Second, when process 0 has more than one node, it will look which process is free and put the node in its area. You see two examples with the result of serial and two parallel versions. When processor number is increasing, parallels take less time than serial. Although we thought that the one-sided approach would take less time than master worker, the results did not come out as we expected. We think that the reason for this is that the process needs to do more control so that they do not suffer race conditions. Stay tuned to reach the detailed report of our project.